This unit's about chemical reactions. To begin with, we're going to learn about the basics about a chemical reaction, and then we're going to learn how to balance the chemical reactions. So to begin with, the very basics of it is that you're going to have your reactants producing your products. So anything on the left side of the arrow are called your reactants. Anything on the right side of your arrow are called your products. You would think this is very simple, but I've had students get this wrong. This slide are the different symbols that you're going to see in a chemical reaction. You have to know what they're for. So first off, an arrow pretty much between your reactants and your products is saying that your reactants produce your products. The plus, just like in math, means plus and. S, L, and G are your states of matter. So if there's an S beside a reactant or product, it means it's a solid and so forth. AQ stands for aqueous. You need to know that aqueous means that the solid is dissolved in water. So not only do you have your solid sitting in there or your solution sitting in there, you also have H2O present as well. If you have a triangle on top of an arrow between your reactants and products, this means your reactants have been heated. So, for example here, this is 2H2G plus O2G produces 2H2OG. So what does this tell you? So first off, it tells you how many by looking at your coefficients. Your coefficients are the big numbers out in front. So in this example, this is saying that you have two hydrogen gases reacting with one oxygen gas, producing two water molecules. Then, what's next is you know your chemical formulas based on what's in the chemical reaction. Again, hydrogen gas plus oxygen gas produces water. Finally, it shows you the states. So in this example, you know that all of your reactants and products are in gas form. Now you also need to remember your diatomics again, just like last unit. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, hydrogen. Remember, anytime that they're mentioned and they're by themselves, they have to have a subscript of 2. The law of conservation of mass. The word conserve means that nothing is lost or gained. So that means the law of conservation of mass means mass is neither created nor destroyed in a chemical reaction. So whatever you start off with is what you're going to end with. So this means your total mass and your atoms stay exactly the same. Your atoms can only rearrange. So for example, you're starting off with 4 hydrogens, they're stuck together, 2 oxygens, they're stuck together, and when the reaction actually occurs, your hydrogens end up splitting those oxygens and pairing with them. So there's still 4 hydrogens, 2 oxygens, 2 oxygens. So the only thing that they are doing is rearranging. Now, to our last step for this video is balancing chemical reactions. So I'm going to quickly go through the steps, but you're going to learn more from actually doing problems. So first you write the unbalanced equation, count atoms on both sides, add coefficients. Remember the coefficients are big numbers. Then you're going to do coefficient times subscripts equals the number of atoms, reduce coefficients if possible, and double check. Now this slide here is probably the most helpful piece of information you're going to get. As we go through this, I'm going to show you what these tips mean. So first off, only balance one element at a time. Update all atom counts after adding a coefficient. If an element appears more than once per side, balance it last. Balance polyatomic ions as single units if they appear unchanged on both sides. So for example, if you have SO4 on both sides, you're simply going to count it as one SO4 instead of 1 sulfur and 4 oxygens. It will make your life easier. You don't have to do it, but again, they're just helpful tips. So let's do our first example. Sodium bromide and chlorine gas react to form sodium chloride and bromine. So in order to do this problem, the first thing is to actually write out what your chemical reaction is. So you have to know that sodium bromide is NaBr. Both have a charge of 1, so when you crisscross, you get NaBr. And means we have a plus sign. Chlorine gas. Now you have to remember that chlorine gas means it's Cl2. React to form that means you have an arrow. Sodium chloride. So sodium chloride is NaCl. Again, both of them have a charge of 1, so all you need is to crisscross and you get NaCl. And is a plus sign, bromine. And bromine again is a diatomic, so you're going to put a subscript of 2. So what this is called is your skeleton equation, meaning it's not showing conservation of mass. It's just showing what chemicals are involved. So your job now is to balance it. So in order to balance it, the first thing you're going to do is list all the different types of elements that there are in the reaction down the middle. So for this one, we have Na, Br, and Cl. Now, you're going to count the atoms on both sides. So you're going to put this down where the arrow is. So now you're able to count the number of atoms on this side and the number of atoms on the other side. So Na, to simply count the number of atoms, remember you look at the subscripts that are attached. So for Na, there's no subscript, so that means there's 1. Bromine, 1. Chlorine, 2, because of that subscript. Now we're going to do the exact same thing on the right side. Na, 1. Bromine, 2. Chlorine, 1. So you can see that this chemical reaction is not balanced because you have the sodiums balanced 1 and 1, but bromine you only have 1 over here and 2 over here. So this is saying that magically you gained a bromine in there, but that is impossible. So then you're going to have to balance it. So to balance it, you're going to add coefficients. The only place that you can add a coefficient is in front of the different chemicals. You cannot put them between your different compounds, only in front of the different things. So Na is balanced, bromine is not. Typically you're going to add a coefficient to the side that has the least amount because that's the one that you can multiply to get the other side. So for this case, you have 1 bromine on the left, 2 on the right. So simply going to ask yourself, what times 1 equals 2? So again, what times 1 equals 2? So your answer should be 2. So what this is saying is that you have to add a coefficient 2 here in order to get the bromines to be balanced. Now to show that they're balanced, you're now going to recount your atoms. Every time you add a coefficient, recount. Because what has happened is when you put this 2 in front, not only does it change the Br, it now changes the Na. So you're simply going to do coefficient times subscript. So 2 times 1 means we now have 2 sodiums on the left. Then 2 times 1 for the bromines. So we now have 2 bromines. Now, in the process of balancing the bromines, because we're now balanced 2 and 2, we messed up our sodiums. So this means we need to go back and look at our sodiums. So we have 2 on the left, 1 on the right. So again, what times 1 equals 2? And your answer should be 2. So every time you add a coefficient, recount. So for sodium, we now have 2 times 1, which is 2. For chlorine, we now have 2 times 1, which is 2. So what does this mean? Now all of our numbers are the same on both sides. Now they don't have to necessarily be exactly the same numbers in a column here, but they do have to match the other side. So what is your answer? Your final answer is your balanced reaction here. So 2NaBr plus Cl2 produces 2NaCl plus Br2. All this is around here is like showing your work in a math class. So let's try another one. Aluminum and copper 2 chloride react to form copper and aluminum chloride. So aluminum is Al. It's not a diatomic, so you can just write it as Al. And means plus. Copper 2 chloride. Now here's where the problem comes in. If you still don't know how to write chemical formulas, you're going to be in trouble. So copper 2 chloride means you have Cu with a charge of 2, chlorine with a charge of 1. So when you crisscross for copper 2 chloride, you get CuCl2. So down here, you should write CuCl2. So if you do that incorrect, your whole answer is going to be wrong. Reacts to form, that means that's an arrow, copper, which is Cu, and aluminum chloride. Again, aluminum chloride, Al, has a charge of 3. Chlorine has a charge of 1. So when you crisscross, you get AlCl3. So you get copper plus AlCl3. So now, we're going to follow the exact same steps. List the elements down the middle. So Al, Cu, Cl. And now we count. Aluminum's on the left. We have 1. Copper on the left, 1. Cl on the left, 2. On the right, 1, 1, and 3. So this is where we hit a problem. What times 2 equals 3? A whole number. Does a whole number times 2 equal 3? And your answer should be no. Now this is where you have to figure out what does 2 and 3 both go into, and your lowest one. So both 2 and 3 go into 6. So then you have to ask yourself, what times 2 equals 6? And that would be a 3. Again, what times 2 equals 6, because that's going to be our magic number in order to make these numbers equal. So now that we put a coefficient, we need to recount. So when we put this 3 here, we now have 3 coppers, and then 3 times 2, which gives us 6 chlorines. So we're still not done with chlorine because we have 6 on the left and 3 on the right. So now we need to do the right side. So what times 3 equals 6? And your answer should be 2 there. So when you do that, we now get 2 times 1 for the aluminums. So now we have 2 aluminums. And then for the chlorines, we get 2 times 3, which is 6 chlorines. So our chlorines are good. Now, in the process of fixing our chlorines, we now mess up our aluminums and copper. So go back to the top and work your way through. So for aluminum, we now have 1 on the left and 2 on the right. So again, typically start on the side that has the least amount. So what times 1 equals 2? And your answer should be 2. So when you do that, we now have 2 times 1, which gives you 2. Your aluminums are good. So now we're going to do the same thing with copper. So what times 1 equals 3? And your answer should be 3. And that's how you know what coefficient to put there. So now 3 times 1 is 3. As you can see, your numbers match on both sides. This means you are done. So your final answer should then be this right here. Your coefficients are 2, 3, 3, 2. So now let's try one that has the formulas already written out for us. So this should be extremely easy, or not extremely easy, but easier. So all we're going to do is list the elements down the middle. So Na, Mg, and Br. And now we count. So Na's on the left, we have 1, Mg, 1, Br, 2. On the right, there's no subscripts, so this means it's all 1s. So the only one that's messed up is Br, because we have 2 on the left and 1 on the right. So you're always going to go with the side with the least amount. So for bromine, we have 2 on the left, 1 on the right. So simply ask yourself, what times 1 equals 2? So your answer for that question should be 2. So now every time you put a coefficient, recount. Sodium is now 2 times 1, which gives us 2. Br is now 2 times 1, which is 2. So bromine's good, but Na is not. We now have 1 and 2. So in the process of balancing Br, Na got messed up. So what times 1 equals 2? Your answer is 2. So now this becomes 2. All the numbers are the same on both sides. This means we're balanced. And this is the final answer. So now what if we add those pesky polyatomics in? So the thing you've got to remember is that if a polyatomic appears on both sides unchanged, you're going to leave it exactly like it is. When we list our elements down the middle, this means we're going to put Ca, NO3, Na, and OH. Now if you noticed, I put my polyatomics in parentheses. I told you this tip back in Unit 4. It's whenever you see a polyatomic, put it in parentheses. And I'm going to repeat myself again. Anytime you have a polyatomic, put it in parentheses. If it's not in parentheses, put them in parentheses. This will stop you from using the numbers inside, because the most common mistake is to use that 3 as if you are balancing it. But you've got to remember that that 3 is part of one nitrate. So because of that, we now are going to count our atoms on both sides. So calcium on the left, there's 1. Nitrates. This is why it's very important to put those parentheses, because if you have a polyatomic, you're going to look at the number outside of the parentheses to determine how many you have. So for nitrate, we have 2. Sodium, 1. Hydroxide, 1. On the right, Ca, 1. Nitrate, 1. Na, 1. Hydroxide, 2. So calcium is good, nitrate is not. So that's where we're going to start. Na, 2 on the left, 1 on the right. What times 1 equals 2? 2. Now we distribute, so 2 sodiums, and now 2 nitrates. Nitrate is good, but in the process of fixing the nitrates, we messed up the sodiums. So what, we're going to go to this side because this is the side that has the least amount. So what times 1 equals 2? 2. And now we recount. So 2 sodiums, 2 hydroxides. Fixing sodium, we also fix hydroxide, and everything is the same. So here is our final answer. Just because the polyatomics look complicated, it's actually the same thing. I now want you to pause the video and see if you can do this one on your own. You should have only gotten a 2 in front of the NaOH because the only things unbalanced are Na and OH. There's 2 on this side, 1 of each on here. Now what if the polyatomic does not appear the same on both sides? Then you have to split it up. So this is an example of that. We have MgOH2, but there's no OH on the other side. So we have to split it up into Mg, O, and H. And you're going to count on both sides. Mg, we have 1. O, on the left side, you have to carry that 2 in, so that means you have 2 oxygens because you're going to simply distribute the 2. Also in distributing the 2, we now have 2 hydrogens. On the right side, 1 magnesium, and oxygen, you have 1 here and 1 there, so that gives us 2. And then hydrogens, we now have 2 on the side. This is an example of where the chemical reaction is already balanced, so you don't have to do anything. The main purpose of this one is to show you that if you have a polyatomic that does not appear the same on both sides, you have to split it up. Now, for the hardest one is your combustion reactions. CH4 plus O2 produces H2O plus CO2. Down the middle, we're going to have C, H, and O. On the left, we have 1 carbon, 4 hydrogens, and 2 oxygens. On the right, 1 carbon, 2 hydrogens. Now the oxygens. And here's my tip. And I'm going to tell you my tip, and if you decide to listen to it, that's going to be amazing. If you decide not to listen to it and you have a hard time doing these, I'm going to tell you to follow my tip. If you have an element that appears on one side, and it appears twice on one side, on top of the actual chemical reaction, I want you to do another number count. So for example, oxygen, in this one, we have 1, plus how many over here, and that's 2. So we have 1 oxygen above water, and we have 2 oxygens in carbon dioxide. That means that our total number down here is 3. There's a purpose for my tip because of a very common mistake that you'll see in just a second. So looking at this, our carbons are good, but our hydrogens are not. We have 1 carbon over here, 1 carbon over here. We're good. 4 hydrogens, 2 hydrogens. Now our oxygens are all messed up too, but if you remember one of my tips, I said if an element appears twice on one side, save it for the very end. So that's what we're going to do. Do not try to balance oxygens before you balance the carbon and hydrogens. So hydrogens, we have 4 on the left, 2 on the right. So what times 2 equals 2? Equals 4. I'm sorry. What times 2 equals 4? So in this case, it's 2. When you do that, you get 2 times 2, which gives you your 4 hydrogens. Now here's where I want to talk about the most common mistake. Is when you do this, when you come up with your new numbers, you're always doing 2 times a subscript to give you the new number at the bottom. So the most common mistake is to do, for the oxygens, 2 times 3, which would give you 6. But that is not how many oxygens you have, because you're not doing 2 times 3 because there is no subscript of 3. You're simply doing 2 times 1. So now in this compound, you have 2 times 1, which gives you 2 oxygens. So when you actually count your number of oxygens, you now have 2 plus 2, which would give you 4. So because of that, now carbon and hydrogen is balanced, you now need to try oxygen. So we have what times 2 equals 4, and you should get a 2 there. And that balances us out.